In this tutorial video, I will be discussing questions related to trigonometry. This will be of great help in answering questions related to trigonometry, especially your summative tests. And also, in this video, I'm going to show to you how we are going to use our fingers to satisfy ourselves. What I mean for satisfy is a satisfaction you can get when you can answer a given problem. Let us start with the first problem. Which trigonometric function is the reciprocal of sine? So if you already read your modules, then this will be very easy to answer. So this will be the choices. Is it sine, secant, cosecant, cotangent? So to answer this problem, let us recall Captain SOHCAHTOA or this mnemonic to remember the first three main ratios, trigonometric ratios or trigonometric function. So we have SOHCAHTOA. So we are going to divide the first three letters, SOH. The S stands for sine, and the two letters after the sine, it tells us what are the parts of the triangle that will be used. So for example, for sine, it is being followed by O and H. O stands for opposite and H stands for hypotenuse. So it means that for the sine function or for the sine ratio, we can get the value of sine ratio by dividing opposite by hypotenuse. So sine is equal to opposite over hypotenuse. The next three letters, we have C, A, and H. It is also for the next function, which is cosine. So when we say cosine, it is defined as adjacent over hypotenuse. So the adjacent side of the given angle over the length of the hypotenuse. And then for the next one, we have TOA. The T stands for tangent. So to get the tangent of an angle, that is just opposite over adjacent. So again, remember, these are the three main ratios or the three main functions. Now, if we have SOHCAHTOA, we also have SOHCAHTOA. So this stands for the three remaining ratios. We have the first one, which is the cosecant, that is hypotenuse over opposite. The next one, we have the SHA, the S stands for secant. So that secant is equal to hypotenuse over adjacent. And then the last one, the C, that is the cotangent, which is adjacent over opposite. So if you observe, comparing the sine and the cosecant, we have opposite over hypotenuse. For cosecant, we have hypotenuse over opposite. So what do you observe with the order? It is being reversed or being reciprocated, because it means that for sine ratio, the reciprocal or the inverse of sine is cosecant. So if we have sine as opposite over hypotenuse, cosecant is hypotenuse over opposite. So they are reciprocal ratios. Same as for cosine, the reciprocal is secant, and then for tangent is cotangent. So going back to the question, which trigonometric function is the reciprocal of sine? Answer is cosecant. And always remember this relationship because it's very important. The reciprocal for sine is cosecant, for cosine it's secant, for tangent it's cotangent. So answer is cosecant. Pinaikot-ikot Second problem, what is sine 45 degrees? Or the question is asking for the value of sine 45 degrees. Now, if you have a calculator, you can just press your calculator, sine and then 45, and then it will give you an answer. So depending on what calculator you have, usually it will give an answer in decimal form. But if you are going to look at the choices, it's in ratio, it's in fractional form. Now, for this video, what I'm going to teach you is a skill or an idea that will be very useful, wherein you can solve this or you can answer this question without using a calculator or without memorizing a table, because usually in the books, this lesson, the trigonometric ratios of special angle, is being represented on a table. So what I'm going to teach you is using our fingers. So this is the satisfaction I'm referring earlier. Satisfaction we get by using our fingers. Now, to do this, imagine this is your hand, and then each finger represents a value. We have 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. All this given value of angle or value, these are special angles. If you can still recall, during the third quarter, we're talking about 30, 45, and 60 as special right triangles. Now, how to do this? For example, we are looking for the value of sine 45. So you take note of the value, which is 45. So 45, so we are going to hold on our finger that signifies or that is equal to 45. So I'm just going to use this one, this symbol. So meaning we are holding on this finger, or bending or holding on our finger, the middle finger. Now we are going to use this formula. For sine theta, you read the symbol as theta. That is equal to the square root of the bottom fingers over 2. So this will be the formula always. For sine theta, that is equal to the square root of the bottom fingers over 2. Now, what do we mean by bottom fingers? When we say bottom fingers, these are the fingers below the finger that we hold on. So in this case, the middle finger. So we are going to count the number of fingers below this finger. So now we have sine 45 because we are looking for the value of sine 45. That is equal to the square root of the bottom finger. So we are going to count how many fingers below this finger that we hold on. So they have 1 and then 2. So we are going to write 2 inside the square root sign. And then after that, we are just going to simplify if it can be simplified. But if not, then that is the answer. So looking at the value square root of 2 over 2, that cannot be simplified further, meaning sine 45 is equal to square root of 2 over 2. Okay, that's an example how we're going to use fingers to satisfy ourselves. Next, for cosine theta, this will be the formula, the square root of top fingers over 2. Now, it's very easy to remember these formulas rather than memorizing the table of the values of these special angles. And then for tangent, it's the combination of sine and cosine, square root of bottom fingers over the square root of top fingers. Okay. Next problem, it's similar to the previous problem so that we can practice more that technique. So here we go again, our hand with our fingers. Now, The angle being stated in the problem is 30 degrees. So we are going to hold on this finger, the 30-degree angle. The problem is, if you are going to look at the formula I gave you earlier, it only have formulas for sine, cosine, and tangent. So this will be the problem that will tell us how useful knowing the reciprocal of each function. Recall that for problem number 1, the reciprocal of sine is cosecant, meaning if we have cosecant, it is also equal to 1 over sine theta, meaning the reciprocal of cosecant is sine. So we can write it in this form. Or cosecant 30 is equal to 1 over sine 30. So understand this relationship in this way. In order to find the value of cosecant 30, we need to find the value of sine 30 and then find its reciprocal. So we use the formula for sine. Sine theta is equal to the square root of bottom fingers over 2. So we can have sine 30, so this is the finger that we hold on, and then count the fingers below this finger. So that is 1. We only have 1. So we put that 1 inside our square root sign or our radical sign, and then simplify if we can simplify. Of course, square root of 1 is equal to 1. That's why we have sine 30 is equal to 1/2. But that is not the problem. The question is, what is cosecant 30? As I said earlier, after getting sine 30, we need to find the reciprocal. And of course, the reciprocal of 1 over 2 is equal to 2 over 1. So that is equal to 2. Okay. Next problem. Determine the exact value of the expression cosine squared 60 plus sine squared 45. Now, if you can encounter this problem, do not be afraid of this square, because it means that we only need to find the value of cosine 60 and sine 45, ignoring first this exponent. So we have the choices. So again, I'll summon the hand with the fingers that are very useful. And then we start with cosine 60. So for the cosine, the formula is the square root of top fingers, the number of top fingers over 2. Now we hold on that finger, the 60 degrees. And now we are going to count how many fingers are above the finger that we hold on. So that is cosine 60 is equal to how many fingers? We only have 1. And then simplify, square root of 1 is 1. That's why cosine 60 is equal to 1/2. And then, as I said earlier, do not focus first on the exponents. You find first the value of cosine 60 as well as this value of sine 45 degrees. So for sine 45, we change the finger that we are going to hold on. This time it's the middle finger representing the 45 degrees. Now, we have sine 45. So we use the formula sine theta is equal to the square root of the bottom fingers over 2. Now, this is the finger that we hold on. So we are going to count how many fingers are below this finger. So 1, 2. So we'll have sine 45 is equal to square root of 2. And we cannot simplify this further. So we have sine 45 equals square root of 2 over 2. Now after getting the two values, we can now proceed in finding the exact value of this expression. So to do that, we write the given, and then this is how you are going to do it. cosine 60 is equal to 1 half. And then after having that value, that's the time you are going to raise it to the power of 2, or you square it. So 1 half squared. So that is for cosine squared 60. That is just the square of cosine 60. And then for sine 45, it follows the same pattern. So square root of 2 over 2, and then you square. So this is just the meaning of this expression. So what we do now is to simplify further. 1 half squared, that is 1 half times 1 half. 1 times 1 is 1. 2 times 2 is 4. That's why we have 1/4. And then for the other added, square root of 2 over 2 square, we have square root of 2 times square root of 2, that is square root of 4. Square root of 4 is equal to 2. 2 times 2 is equal to 4. And then we have two fractions, 1/4 and 2 over 4. They have similar denominators, so we can add the numerators 1 and 2, that is equal to 3/4. And that's it. Answer is 3/4. Given right triangle A and D, find the 6 trigonometric ratios of theta. So this symbol again is theta. Theta. Now we are asked to find the 6 trigonometric ratios of theta. So again, if we're talking about the 6 trigonometric ratios, the mnemonic we are going to remember is SOHCAHTOA. Captain SOHCAHTOA. So if you want to see the picture of SOHCAHTOA, that is the picture of SOHCAHTOA. Just kidding. Now for so, again, I already explained this one earlier. That is sine given to be opposite over hypotenuse. So it's very important that we know what is our reference angle. So this time our reference angle is theta, and it is located on this angle theta, or that is angle D. Now to find the 6 trigonometric ratios, we start with sine. Sine is defined as opposite over hypotenuse. So this is how you are going to do it. You look at the angle, you ask yourselves, what is the opposite side of this angle? So when you say opposite, just look at directly what's the opposite, and that is side D. And then after that, you ask yourselves again, what is the hypotenuse for H? Hypotenuse is always N. So that is sine theta is equal to D over N. Now, for every right triangle, the hypotenuse will not change. That is always the opposite of the 90-degree angle or the right angle. For opposite and adjacent, it will change depending on our reference angle. So for example, if this is our reference angle, the opposite is D, side D. But if this is our reference angle, the opposite side will become A, not D anymore. So it will depend on our reference angle. Next ratio is cosine. Cosine is defined as adjacent over hypotenuse. So again, you ask yourselves, what is the opposite side? Adjacent. What is the adjacent side of this angle? When we say adjacent, in vernacular, that is tapad. Or which side is touching that angle or forming that angle? Actually, there are two sides, but one of the side is the hypotenuse, so that is out. So this is the adjacent side, which is represented by A. And then the hypotenuse, again, it will not change, that is N. So cosine theta is equal to A over N. Next, we have tangent. Tangent is defined as opposite over adjacent. So for opposite over adjacent, this is our reference angle. What is the opposite side? That is D. Adjacent side is A. So tangent theta is D over A. So that is for SOHCAHTOA. And then another captain SOHCAHTOA. That is the reciprocal. So if this is captain SOHCAHTOA, this is captain SOHCAHTOA. See? Okay, now for cosecant theta, so that it will be faster, just look at the value of sine theta because we know that they are reciprocal, and then just twist it upside down and you will have n over d because it's just the reciprocal. Then for for secant, it's the reciprocal of cosine, so instead of a over n, that will become n over a. And lastly, for cotangent, the reciprocal of tangent, so instead of d over a, that is a over d. And that's it. Again, remember, this is SOHCAHTOA, so SOHCAHTOA will look like this. Given right triangle A and D, solve for tangent theta. So this is right triangle A and D. Another important information, if in the problem it is not stated what is the right angle, usually what letter is in the middle of the name of the triangle is the right angle. So for example, A and D, N is in the middle, so N is the right angle. So these are the given. N is given to be equal to 21, A is equal to 9, D is equal to 10. The question is very simple. You solve for tangent theta. So you are just going to recall how do we define tangent. So that is TOA from SOHCAHTOA. Tangent is opposite over adjacent. So again, you ask yourself what will be the reference angle. Reference angle is theta. So you look at where, or you find where theta is located. So that is on angle D, or this is theta. Now you ask yourself, how long is the opposite side? So if this is the reference angle, the opposite side is equal to 10. So that's why, or that is side D. And then for the adjacent side, that is side A. So with reference to this angle. Now what we need to do is substitute. Tangent theta is equal to D is equal to 10. A is equal to 9. And then it will depend what kind of choices do we have. So for example, if the choices is in fraction form, then this is already good as the final answer. But if you want it on decimal, tangent theta equals 1.11. In a right triangle, if two legs are given, what trigonometric ratio can be used in solving the missing measurement? So to answer this problem, just analyze. In a right triangle, if two legs are given, what trigonometric ratio can be used in solving the missing measurement? So you focus with two legs because when we have a right triangle, we have three sides. Among the three sides, we have that side opposite the right angle and we call it the hypotenuse. The remaining two sides are the legs, and we are asked what trigonometric ratio. So we are just going to define each ratio. If it contains a hypotenuse, then we cannot use that ratio. For example, cosine. Cosine is equal to adjacent over hypotenuse. So we have the hypotenuse, that is already x. Tangent ratio. Tangent is TOA, opposite over adjacent. So we do not have a hypotenuse, so that is check. How about sine ratio? Sine ratio is opposite over hypotenuse, that is so. So that is x. Now none of this, because we already have a check, then this is also x. Therefore, the ratio that can we use in solving the missing measurement if two legs are given is tangent. In triangle YOU with angle O as the right angle, YU, or the length of segment YU is equal to 12 centimeters and OU is equal to 8 centimeters. What is cosine U? So this will be the figure. If the figure is not given, then you can make your own figure to have a clearer understanding of the problem. Triangle YOU, so we can have YOU with emphasis that angle O is the right angle. So usually what's in the middle, that is the right angle. Now, YU, not me, is equal to 12 centimeters. So, this one. So, YU is also side O. So, that is equal to 12 centimeters. And OU is equal to 8 centimeters. So, we have 12 centimeters and 8 centimeters. And then, this side, the length of this side is not given. But actually, if this side is needed in the problem, then we can find the length of this side using the Pythagorean theorem. Now the question is, what is cosine U? So you look at angle U. So this is that angle U. Now we are talking about cosine, so that should be adjacent over hypotenuse. So if this is the angle, you ask yourself, what is the adjacent side? And since U is not involved because the adjacent side is 8, the hypotenuse is 12, we don't need to find the value of U or the length of U. But anyway, if the problem requires the length of U, just use Pythagorean theorem. Now for cosine U, you use the definition, adjacent over hypotenuse. So how long is the adjacent side? That is equal to 8. How long is the hypotenuse? Hypotenuse is equal to 12. Now, the basic rule for function, always simplify in its lowest term. So, 8 and 12 are divisible by 4. 8 divided by 4 is equal to 2. 12 divided by 4 is equal to 3. Therefore, answer is 2/3. Next problem, a kite with a string of 100 meters makes an angle of elevation with a ground of 60 degrees. How high is the kite above the ground to the nearest meter? So these are the choices. Again, if figure is not given, you can make your figure. And then since this is right triangle trigonometry, then we are expected to have a right triangle. So we can start by drawing a right triangle. You don't need to have a very beautiful drawing. What you need is a precise and accurate drawing. So to make it precise, you start with a right triangle because we are expected to have a right triangle. And then we have a kite. Of course, a kite with a string of 100 meters makes an angle of elevation with the ground of 60 degrees. Meaning, when we have angle of elevation, meaning the observer is here, so the kite should be up above. So we have kite. Kite is somewhere here. This is the ground. It makes an angle of elevation with the ground of 60 degrees. So from the ground, this is the observer, maybe the one holding the string of the kite is somewhere here. So if the observer is looking on the object above, the angle formed between the horizontal line and the line of sight is the angle of elevation, and that is given to be 60 degrees. Now, the length of the string is equal to 100 meters. The question is, how high is the kite above the ground to the nearest meter? How high above the ground? So it means we are going to find the length of this side. Now, this question is under trigonometry, but if you can recall, if this angle measures 60 degrees, automatically this also measures 30 degrees. This angle measures 30 degrees. Because in a triangle, the sum should be 180. Since this is a right angle, it measures 90. 90 plus 60 is 150 plus 30 is 180. So if you are going to look at the figure, we have 30, 60, 90. For sure, you can remember that this is one of the special triangle, right triangle, the 30, 60, 90 right triangle. Now, instead of using trigonometric ratios, we can use what we learned before. If this is a 30, 60, 90 right triangle, and if this is the hypotenuse, and this is the 30-degree angle, meaning this is the shorter side And recall that the shorter side is 1/2 the length of the hypotenuse. So this should be 50 meters. And the length of the longer leg, that is shorter leg times the square root of 3. That's why this leg or this side should be equal to 50 square root of 3 meters. So see, we were able to find the length of this side without using trigonometric ratio by just applying the idea about special triangle. Now, if you look at the choices, there is no 50 square root of 3. So we need to solve what's the value of 50 square root of 3. So using our calculator, my calculator, it gives me the value of 86.60. But in the question, it says to the nearest meter, so we are going to round up. So that is 87 meters. Next, and the last question. A ladder 10 meters long leans against the wall of a building. If the foot of the ladder makes an angle of 65 degrees with the ground, how far is the base of the ladder from the wall? So again, this is one of the application of right triangle trigonometry. So I'm going to draw a right triangle and then understand and analyze the problem. A ladder is leaning against the wall. So this should be the wall. And this is the ladder. According to the problem, it is 10 meters long. And the foot of the ladder, since this is the ladder, so the foot of the ladder is somewhere here. It makes an angle of 65 degrees with the ground. So this is the ground. It makes an angle of 65 degrees. How far is the base of the ladder from the wall? So how far is the base of the ladder? The base of the ladder and then from the wall. So we are looking for the length of this side. Now, if you are going to use the 30, 60, 90 as a basis, if this is 65, this is 25. If this is 10 meters, then if this is just a 30, 60, 90 triangle, this should be 5. If this is 30 but this is less than 30, so answer should be less than 5. If you are going to look at the choices, there is only one that is less than 5. So I guess answer is letter D without solving the problem. But guessing is not enough. We need to have a solution. So now, to solve this problem, just focus on the given, especially with the given angle, 65 degrees. And then, next thing you are going to do is to ask yourself, with respect to this angle, what is this 10 meters? With respect to this angle, what is this 10 meters? And I know, you will know that it is the hypotenuse because that is opposite of the right angle. And it will not change. That is always the hypotenuse. Now, after that, so we already have the given. Next thing we're going to do is to ask ourselves, with respect to this angle, what is this missing side? With respect to this angle, what is this missing side? And surely you can answer, sir, it's the adjacent side because it's very obvious. This side is the adjacent side of this angle. After that, you recall what ratio to make it easier. Just focus on the three main ratios, the sine, cosine, and tangent. What ratio contains adjacent and hypotenuse? And of course, if you are always answering problem like this, automatically it will give you an answer of cosine. Cosine because cosine is equal to adjacent over hypotenuse. So now, cosine 65 is equal to adjacent. Since this side is missing, we can use a variable. So for example, V or Bianca. And then, the hypotenuse. We do not use a variable because it's given. Hypotenuse is given to be 10. So, cosine 65 is equal to V over 10. And now we are going to apply what you learned about cross multiplication. So we cross multiply. Of course, tan and cosine 65 will go together when we cross multiply. And v and the denominator, which is 1. Okay? So v times 1 is equal to v. Now using your calculator, just press 10 and then cosine 65, it will give you an answer of 4.23. Therefore, the foot of the ladder is 4.23 meters from the... Thank you for watching, and you share it. Grade 9 friends. Thank you.